Okay, students, so today we will see impact. Okay, it is so impact, it is a collision between two bodies which takes place for short interval of time during which each body exerts a large force on the other body. Okay, so say consider this one body and this other body. If these are coming from this direction and this direction and they are colliding here, okay, they are having an impact there. Okay, so their collision is for short interval of time, and in that time they exert large force on each other. That is the definition. Now so this is the plane of impact. Along this plane these two bodies collide with each other, and normal to the plane of impact is line of impact. So this is line of impact. Okay, so we will see few definitions and theory bit for this. So first, line of impact, it is a common normal to the plane of contact. So this is common normal to it. Next is central impact. If mass centers of the both the bodies are on the line of impact, then it is called as central impact. Now you can consider mass centers similar to the center of gravity. Okay, so if the mass centers of the both bodies are on the line of impact, then it is called as central impact. Next, direct impact. If direction of velocities of each body is along the line of impact, then it is called as direct impact. Okay, next, time of deformation. During impact there is a change in shape and size of the body. Okay, uh, it is called deformation, and this continues for small interval of time. This time is called as time of deformation. Next, time of restitution. After deformation each body tries to regain its original shape and size. This is called restitution or restoration. Okay, this takes place over a short interval of time, and this time is called as time of restitution or restoration. Okay, next, if u1 bar and u2 bar are the velocities of bodies before impact, and v1 bar and v2 bar are the velocities after the impact. Okay, so we have one equation: v2 bar minus v1 bar is equals to minus of e into bracket u2 bar minus u1 bar, or we can write it like this: e is equals to minus of ratio of v2 minus v1 upon u2 minus u1. Okay, so where the value of e lies between 0 and 1, 0 less than e less than 1. Okay, next, coefficient of restitution is the ratio of relative velocities after impact to the relative velocities before impact. So v2 v1 are the relative velocities after the impact, and u2 u1 are the relative velocities before the impact. It's a ratio, negative ratio of uh, relative velocities after impact to relative velocity before the impact. Remember, value of e always lies between 0 and 1. Okay, it cannot be greater than 1 and it cannot be lesser than 1, lesser than 0. Okay, so e, another way of defining e is like this: e is equals to minus of impulse due to restitution or restoration divided by impulse due to deformation. Okay, now conservation of momentum. We know momentum is mass into velocity, so that conservation of momentum law: total momentum before the impact is equals to total momentum after the impact. m1 u1 bar, momentum of first particle or first object, plus m2 u2 bar, momentum of second object. All this is before the impact, is equals to m1 v1 bar plus m2 v2 bar. Okay, taking positive sign towards the right hand side, or towards right. Okay, so m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Okay, next, Loss of kinetic energy during the impact. We know during the impact kinetic energy loss takes place. Obviously kinetic energy before the impact is much more, and after the impact it is less. uh, okay, so during impact momentum is conserved but kinetic energy is lost. So initial kinetic energy half of m1 u1 square plus half of m2 u2 square. Okay, and final ke half of m1 v1 square plus half of m2 v2 square. Okay, now loss of ke is initial ke minus final ke, because initial ke is more, final ke is less. Okay, so loss of ke is equals to so we can write it like this: m1 into m2 into bracket 1 minus e square into another bracket u1 minus u2 bracket square divided by 2 into bracket m1 plus m2. Okay, so this times this formula is rarely used and this formula is used most of the times. Next, we will see now type of impact. There are four types of impact. Okay, so types of impact: first is perfectly elastic impact. Okay, so here momentum is conserved. M1 U1 is equals to M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Okay, second, here KE kinetic energy is also conserved. Okay, half of m1 u1 square plus half of m2 u2 square is equals to half of m1 v1 square plus half of m2 v2 square. Kinetic energy combined together before the impact is equal to kinetic energy combined together after the impact. Kinetic energy is conserved as well as momentum is conserved. Next, coefficient of restitution E is equals to 1. This is the highest value to which it can rise. So E is equals to 1. Two bodies separate after the impact. After the impact, two bodies got separated. There is no permanent deformation or de-shaping of the objects. Okay, so this is perfectly elastic impact. As the name suggests, this type of impact happens between two perfectly elastic bodies. Okay, next, partially elastic impact. Partially elastic impact. See here, momentum is conserved. Momentum is conserved first. Second, kinetic energy is not conserved. So that means loss of kinetic energy takes place during the impact. Okay, next, coefficient of restitution is less than 1. Okay, here it was 1, here it is less than 1. 0 less than 0 less than e less than 1. Next, some permanent deformation remains into colliding objects. Next, two bodies separate after the impact. Here also two bodies got separated and they move with different velocities. Here also two bodies got separate and they move with different velocities. Now this one was partially elastic impact. Momentum is conserved as in the earlier one. Kinetic energy is not conserved. Okay, this was not here. Next, E value is less than 1. Some permanent deformation is there and two bodies separate after the impact. There is third type of impact. It is called plastic impact. So if two bodies move together after the impact with common velocities, then it is called as plastic impact. That means two bodies move together with same common velocity. That means these two bodies do not get separated after the impact. Okay, so next, momentum is conserved. Yes, that is true here also. M1 U1 plus M2 U2 is equals to M1 plus M2 in outside the bracket V, because velocity is common. Okay, so momentum is conserved in this way. Then there is a loss of much larger loss of kinetic energy. Okay, and coefficient of restitution E is equals to 0. So E is equals to 0 here. In earlier case it was in between 0 and 1. In the perfectly elastic impact it was 1. Okay, here E is 0 because obviously V2 minus V1 is 0. Next, uh, fourth type of impact, which is important one for numericals: impact with fixed surface. Okay, so this is used in case where a ball is made to strike with the surface of earth or ground, where one body is of much larger mass than the other, okay, or it is a fixed surface. If a body of mass m moving with velocity u strikes a wall or earth like large mass with a fixed surface or of infinite mass, so this type of impact takes place there. So where one body strikes with another body of infinite large mass like earth, okay. So here, see what happens. First, momentum is not conserved. Momentum is not conserved. In earlier three cases, momentum was conserved, but here the momentum is not conserved. Coefficient of restitution E is equals to minus V upon U. Okay, so V velocity after the impact, and next is loss of KE, kinetic energy is lost. Okay.